Hi, I'm Scott Adams, a graduate student at The Ohio State University. In this short video, I will summarize the paper, The Supernova Impostor 1997 BS, Losses First Supernova, that I authored with First Kochanek. Supernova imposters are a class of stellar transients that are considered to be false positives in supernova surveys. These transients are characterized by type 2n spectra, but have lower peak luminosities than typical core collapse supernovae. The class is heterogeneous, but a subset of these events are some type of eruptive transient that is often associated with luminous blue variables. Inspired by the phenomenology of Edekrina, the most widely accepted picture of the imposters is that they are non-terminal eruptions of massive stars that eject a significant amount of mass that then may obscure the surviving star. If this is the case, one would expect these stars to eventually re-brighten as the optical depth of an ejected shell is inversely proportional to time squared at late times. We investigate if this is the case for the archetypical impostor supernova 1997 BS by obtaining new Hubble and Spitzer observations, monitoring it with a large binocular telescope, and by modeling spectral energy distribution for different possible dust configurations. The new data clearly lacks a source with a flux comparable to the progenitor of 97 BS, which is shown in the bottom right panel for comparison. Likewise, there is no obvious point source in the Spitzer images. Here we present candidate detections of emission in V and I bands, along with limits in UV and the near and mid-IR with the open black pentagons. The best fit model SED for an expanding shell scenario is shown by the solid black line, while the dotted magenta line gives an unobscured model spectrum of the same temperature fitted to the progenitor detection. The time evolution of the flux from 97 BS rules out the expanding shell scenario. The best fit model evolved backwards in time to 2009, shown by the solid blue line, is in gross violation of photometry from HST in 2009, shown by the blue open triangles. We also find that it is unlikely that a surviving star is hidden by a dusty wind. Here in the first three panels we show our Markov chain Monte Carlo results for the temperature and luminosity of a possible surviving star based on our photometry if only the labeled filters are considered detections while the other filters are taken as upper limits. The points are color-coded by their optical depths. The limit on the progenitor is given by the black line. The bottom right panel shows the maximum luminosity possible for a surviving star with an optical depth of 0, 1, 3, and 10. While the figure appears to show that a hot star with only slightly diminished luminosity might be able to survive beneath a thick wind, the high mass loss rate needed for self-shielding so that dust can form in the wind of a hot star would result in an optical depth that would not allow the candidate optical detections we find and that other groups have previously reported. Likewise, it is unlikely that the low luminosity could solely be the result of a large bolometric correction. The only remaining possibility that would allow 97 BS to be a non-terminal event is that the progenitor survived the event with a diminished luminosity. If a surviving star is unobscured and its temperature is unchanged from pre-eruption, it must be at least a factor of 30 fainter than the progenitor. No reasonable mechanism could so drastically diminish the intrinsic luminosity of the star. Even if we allow a collusion of a dusty wind with a reasonable increase in the stellar temperature, the luminosity of a surviving star must still be 25% less than that of the progenitor. In the end, our late-time observations are most easily understood if 97 BS was a genuine supernova. 97 BS could have ejected more nickel-56 than faint type 2p supernovae if we interpret the red color of the post-peak light curve as the result of extinction with no surviving star. Any residual flux that we may detect at the position of 97 BS could be the result of the shock interaction of 97 BS with its circumstellar medium. Thus, 97 BS could be a type 2n analog of a faint type 2p supernova. Theoretical work by Ugliano et al. And Peha and Thompson suggests that multiple progenitor mass windows may give rise to weak supernovae. Meanwhile, recent observational work by Spiro et al. Suggests that faint 2Ps arise from the low mass window of 10 to 15 solar masses. Perhaps 97 BS and similar imposters arise from low energy explosions of stars in the higher mass windows. Thanks for watching this video. For more information, please read our paper.